Welcome everyone. My name is Peter Knol. I'm located in the Netherlands and I'm head of product and supplier management. Welcome to today's RS and FLIR webinar, which is all about transitioning from reactive to predictive maintenance. Before we start, what you are actually coming for, I wanted to very briefly do an introduction on RS. RS is a well-known brand around the world, and we are the preferred high service distributor for over 1 million customers. We bring the latest technologies and best of class content, as well as digital experiences, and through our sales team, the human touch to support you on your premises. We range more than 1 million products today and serve customers across all industries. Our focus is on discrete manufacturing, process manufacturing, energy and utilities, facilities and intralogistics, and much, much more. We are here as your trusted problem solver and deliver excellence through a connected experience and a suite of valued product and service solutions for industrial, MRO, and design customers. Now over to today's session, which is hosted by FLIR, one of our highly valued partners who manufacture high-end test and measurement equipment. And FLIR is set to be the sixth sense you need in your operations to ensure uptime and reduce cost by knowing when something needs replacing before it starts costing you much more than you want. Over to you, Heliel. I can't hear you.
Thank you so much for that introduction, Peter. So I'm Heliel Morales with FLIR. I'm in the global business development team. And as Peter mentioned, today we're going to help you go from reactive to predictive maintenance. We have a really full agenda here. So we're going to go through the introduction to predictive maintenance. We're going to talk to you about some success stories and ROIs. We're going to touch a little bit on the science of both thermal imaging and acoustic imaging. We're going to be talking about complementary meters, but also software. And then we're going to have a Q&A session and the closing. Please do type your questions in the chat box, and we'll be able to get to those at the end of the presentation. And with that, let's get started. So the first thing I want to discuss with you is about your plan. Do you have a plan to deal with unscheduled downtime? And we know it's unpredictable. We know that a lot can happen, very quickly. So having a plan in place and having reliability-centered maintenance is crucial to your operation. So we're going to be talking to you about the different technologies and different things you can do to make sure that you can prevent unscheduled downtime and improve productivity, but also keep your employees safe. The first thing I want to share with you, this is a documented survey that RS did recently, early this year, and it's called Performance in Focus, and it's about the 2024 Maintenance Engineering Report. I just extracted some key elements here. The first thing, and as you can see, is what are the biggest drivers for unscheduled plant downtime? You can see, starting from the left, aging assets is the biggest contributor. And then you go down and you see mechanical failure. Obviously, as you need to replace products, you have to deal with the lead time of those replacement products. So that was also a significant problem when it came to downtime. Operator error at 11%, and then you have at 7% lack of skills. So when we asked this large group of people what they plan on doing to decrease unscheduled downtime in their plants, there was 3 things that stood out. One was upgrading the equipment. Number 2, same percentage, as you can see, both at 49%, improved training. So getting people, right, the training they need to do their jobs. But most importantly, right, also here is introducing some sort of preventative maintenance strategy, which in many cases they didn't have. Many of you have seen what we refer to as the PF curve. So you have your proactive domain, on the far left, and then you get into predictive, right, and all the different technologies that can help you there. And then you have the reactive domain, right? The moment you see smoke, the moment you can smell, right, that something's burning, you have to move really, really fast. And as you get to that point, right, getting closer to the point of failure, you have a short interval and you have to increase the frequency of inspection. So ideally, right, we all want to be in the proactive domain, but you know, we need to have a system and a strategy in place to be able to, you know, deal with the predictive and reactive domains as well. So let me talk to you about some interesting application stories, some case studies, you know, how companies that implemented these types of programs, how it's helped them, and how, you know, they've saved a lot of money. So this particular one is steel mill. So by introducing IR, they were able to, you know, reduce the amount of time needed, right, to do those inspections from 30 minutes down to 5. So as you can see, it's 25,000 euro savings, right? This is just the steel mill. If you look at, for example, this particular hospital, they have 800 steam traps. Energy efficiency and energy usage, it's a big concern in hospitals. So by being able to inspect and troubleshoot these steam traps, they could save anywhere from 100,000 to 300,000 euros a year. We also worked with an insurance company just to get a sense of, you know, how much money can be saved by introducing IR surveys. So here you can get a sense of, you know, how much was saved. There's also, right, so you can do your own calculations. You know your, you know, the energy loss, you know, the cost per kilowatt. So you can pretty much just, you know, plug in the numbers and use this formula to calculate the energy savings from introducing these types of predictive programs. Let's get a little bit into the science of thermal imaging. We've heard the phrase, a picture's worth 1,000 words. Let's put that to the test here with infrared technology. We've all seen the spot thermometer, right? IR thermometer, IR gun, spot radiometer, laser thermometer, many different names for this type of product that allows you to scan the surface and it gives you one temperature reading, right? It's the average of everything it sees at that distance, and it gives you a temperature measurement. It, you know, short distances that work really well. They're relatively low priced, although as you get into higher performance, higher temperature ranges, they can be very pricey. But you know, it's a technology that had been used for many years. But back to, you know, being a single spot measurement, it measures one spot. So when you're scanning your target, right, you're basically just, you know, looking at every single place, right, within your target. You're not scanning, trying to guess where the problem is. And it's a bit of guesswork, right? And maybe you'll hit the right spot, maybe you miss it altogether. But when you have an infrared camera, that's when you see the full image, right? It's a picture worth 1,000 words here. You can draw boxes, areas of interest, you know, the highest temperature spot, lowest. You can do a lot of different things once you have that thermal image. This is a thermal image, right? Not the actual image, but this is the data behind those images. So think of an infrared camera as thousands and thousands of those infrared thermometers. So you still get that data for each of those measurement spots. But what we do, we take all that data and turn it into an image that's actionable. Let me tell you how that works, right? So you have your infrared radiation that hits the detector. Then obviously there's going to be a lot of calculations that happen inside the camera. We assign temperature values to each of those pixels, and from those temperature values, as you saw previously, we can now create an image that's more actionable and easier to work with, easier to add to a report, easier to share with our colleagues. Let's talk about pixels for a second. So if you look at, you know, the thermal image, and as it relates to accuracy, you can see this 1 pixel, you can see the hotspot, right? And you can see a rectangle. The camera is measuring 26.2 degrees Celsius, right? So you're getting the average of all the measurements inside that rectangle, inside that pixel. Now you have 4 pixels on target, and now you're getting a little bit, more accurate because you're able to measure, a smaller target. So now you're at 37.1. But the moment you get a 3x3, you get 9 pixels on target. Now you see how the real temperature, right, is 48.5 degrees. So resolution matters. Resolution drives accuracy. And understanding these basic principles of, being able to understand the distance, what kind of optics I need, what kind of resolution I need for my application are really, really important. As a recap, I'm sure you've all seen many different applications for thermal, but I wanted to give you a quick overview. When you look at electrical, there's a high number of places where you can deploy thermal in your facility. Many, many different applications. As you can see on the screen, there's also many different applications in mechanical systems, right? There's also a number of applications in what we call building diagnostics, right? Finding air leaks, energy efficiency problems, finding roof leaks or any sort of damage from rain or flood. And then there's a wide number of other types of applications, whether it's perimeter security or disease control, environmental, research and development, even in agriculture, we're able to use thermal imaging. So many, many different applications. When you're investing in this technology, you'll be able to use it for many different things. So the ROI is always going to be there. But how do we choose the right camera? So what you see on the screen now is a screenshot from the RS website, right? So you go into the thermal imaging category, obviously FLIR, you choose that as the brand, is enough, right? And then you get into, well, what else is important to me? Is it the temperature of my targets? Is it the resolution? Is it the interface? Does it have a touch screen? Does it have wireless connectivity? What the refresh rate is of that image? So all of these are criteria that you can select as you go on the RS website and you try to find the product that's right for you. So I invite you to visit the RS website and look through this selector tool to help guide you. And we're always available, the RS team and the FLIR team, to help you find the right solution for your application. It's not just about the camera, but all the different tools that you could use on a predictive maintenance program. We also offer training. So, what I talked about just now is a very basic science of infrared. But if you want to become a level 1 certified, we offer that too. So I put information here on the screen and a website where you can go. You can take online courses, you can take in-person courses and be level 1, 2, or 3 certified for infrared. So an invitation if you do want to learn more about the technology. Let's switch gears a little bit, and you're gonna see, similarities between these two technologies. We just talked about infrared, but now we're gonna be talking about ultrasound, right? What is ultrasound? So basically looking at sound waves, right, and that we can't hear ourselves. So we need special equipment to be able to hear those sounds. But you're gonna get those types of sounds from electrical equipment, from leaks, from vibration. So being able to find those issues with an ultrasonic camera, that's going to be very useful in predictive maintenance. And as we said before, right, when we showed the PF curve, you're looking for early warning of impeding failure. So this is ultrasound. So let's talk about kind of the analogy to the spot thermometer. So we've had, right, single microphone products in the market for a long time. Those require interpretation, right? You're not seeing an image, you're just getting information from a single microphone on the screen. So you have to interpret that data There's also accessories that you need for specific use cases. So with ultrasound imaging, you're basically seeing a full image, and on the screen, you can clearly, right, note where that leak is happening. So you can see here on the right-hand side on the camera screen. So here you have multiple microphones. So in this particular case, it's 124 microphones. So they can triangulate and they can, you know, give you a better idea of where that sound is coming from. So again, it's about pinpointing, it's about finding the area where we have a potential failure. And because you have an imaging device, right, you're not necessarily scanning, right, spending time scanning different points. You get a full picture. You can now work 90% faster. And this is so easy to use. It's like using a camera. So just scanning and you'll see it right on the screen. And it's not just about scanning, it's about documenting, right, the potential problem. What are the different applications for ultrasound? So we have, for example, partial discharge, compressed air systems, vacuum leak detection, basically any compressed gas, you'll be able to find leaks, right? In product design, I mean, you can see the many different applications for ultrasound imaging. So it's, and as far as, you know, how to choose the right camera, so we have models for partial discharge. So you see the dash PD. We have models for leak detection, and the Pro unit does both, right? So you can do both partial discharge and leak detection with a single camera. There's also an SI2X for hazardous environments, and that one is a very new addition to our portfolio. So how does it find partial discharge, right? So when you have this type of situation and you create this corona effect, the camera is able to see it and note it right on the screen. And not only that, the camera can quantify and, you know, give you an idea of classification of what kind of partial discharge it is. So you get a lot more context, not just the image, but the severity of the situation. So again, very important in substations, this application. So there's also leaks, right? So you have anything that's pressurized is going to create turbulence, right? And that creates ultrasonic sound waves. So it's very easy, as you can see here on the screen, to find where that pressurized air or gas is leaking into the environment. And being able to find it is quite easy with an ultrasonic imaging camera. So you can see in the screen above is a compressed air system leak. You can very clearly see it. And this one shows a refrigerant gas leak as well. So again, just quite easy to scan, find the problem, and document it. So quick summary on ultrasound, right? It's very effective and is used in many different applications, whether it's partial discharge or leaks. It's quite simple to use. It's, again, because it's imaging and it gives you a full context of what you're looking at, it's going to be much faster. There's obviously the frequency in which it operates. Obviously, as you have more microphones, you can detect better. And yeah, severity assessment and the quantification, being able to use software along with the camera. There's also another set of products that, you know, maybe you already have in your tool bag, or maybe you don't have this yet, but I wanted to talk about the quantification of your findings. So if something in an electrical system is overheating, you will need to know if that temperature rise is driven by an increase in load, right, in amps, and that's where multimeters and quant meters come into play. There's also on the mechanical side, whether, you know, you need to figure out if there's some sort of problem with the motors, right, being able to measure insulation, but also being able to deploy vibration sensors, as you can see in the bottom right here. So there's a lot of different types of complementary products that you can look at. from multimeters, clamps, DMMs, and vibration. The other types of device I wanted to share with you here is what we call IGM, infrared guided measurement. So think of all this infrared technology that we talked about at the beginning of the webinar, but is now part of your traditional electrical meter. So what you see at the top is a multimeter that does all your traditional electrical measurements, but you have this IGM functionality that activates an infrared camera. So with the same device, you're able to scan, find potential areas of problem, and then go in and take a measurement. Similarly, right, a clamp meter, you can scan, make sure it's safe to approach with your test leads and get all those readings. In some cases, the electrical equipment, right, is behind a cabinet, a door, right? So you have this electrical cabinet, and being able to inspect these cabinets, if you don't have infrared windows, can be quite complex. So there's a certain level of protective equipment that is needed. You're opening that door, you're creating, obviously, oxygen is coming in, and it could lead to arc flash. But with infrared windows, you can have this on the door. You can do your thermal and visual inspections from a safe distance and without, de-energizing, without opening that cabinet door. So I wanted to just share with you that even when certain pieces of equipment is not readily accessible, there is an option through infrared windows to be able to inspect them on a regular cadence. Last but not least, software, right? So we're capturing images, we're capturing data, we're capturing measurements. We want to be able to keep track of the trends. Is something getting worse? How much worse is it getting? Who needs to know about this information? Who needs to act on some of these findings? So whether you want to use a specific software for IR, or you want to integrate infrared and the other technologies into your system, FLIR RS can help you, right? So what you see on the screen, top left, is a desktop program, Thermal Studio. We have the mobile app. With the SDK, it's very easy to just take all that information and put it into your system, your CMMS, your asset management system. Ignite, right here in the middle, is a cloud software. So being able to download those images, have a backup on a cloud, but it's not just about storage, it's about being able to analyze those images and create reports right from a web browser. So quite powerful. And then, obviously, all the acoustic measurements as well, converging with thermal and the other types of readings. So software should not should be considered, right, when you're integrating, when you're setting up a predictive maintenance program. So think of what is the right software package for you. How do you want to integrate into your existing systems? So let's take a step back and just look at what we said at the very beginning of our presentation. We want to share with you how you could transition from reactive to predictive, right? And here are the 5 things that we recommend. One, you need to have a maintenance strategy, right? It starts with that strategy. It starts with the need and the urgency and the drive to have this maintenance strategy. Then introducing thermal imaging, but in many cases, you may already be using thermal, so scaling up the use of thermal imaging technology. There is a use of meters with advanced features and connectivity, right? We talked about IGM. There's acoustic imaging, even if you had not looked at acoustic in the past. So now, the technology is there. It's quite accessible, and it should be part of your maintenance programs. And selecting the right software, it's quite important. So those are the top 5 things. So now we have time for some questions. I hope you've been able to type some of those questions. Peter, do we have any questions?
Yeah, definitely. Thank you. We've received multiple questions in the chat.
Okay.
Thank you, everyone. But first of all, Heliel, thank you very much for taking us through this exciting piece of content. I've learned a few things over the course of this training. I've been starting to work on thermal imaging with the police when I was in sales to identify in areas where people do things that the law prohibits them to do. And then with thermal imaging in the colder circumstances, you can find houses that perhaps do things they shouldn't be doing. So your technology is appreciated there as well. Now, when we started working with FLIR on the strategic partnership and support the customers in field, we first of all needed to train our people in the field as well, our salespeople. Now, one of the questions that we received in the chat is, how much training is needed to operate a thermal camera?
Yeah, so it's quite, that's a great question, right? Because you can always, as I mentioned, there's this infrared training level 1, 2, and 3, but ultimately is an imaging device, very simple to use. There's the intuitive user interface. We actually store JPEG images, so being able to download those images from the camera and attach to an email is quite simple. So understanding the principles of IR, right? Distance, spot size ratio, temperature ranges, emissivity, reflections, those are important concepts to know. So I recommend, right, at least a basic course on thermography just to make sure that you're getting the most out of your camera. But there, as far as operating the camera itself is quite simple.
Yeah, thank you for explaining. So the other question is then also related to how simple are these things? Because the question is, can you make adjustments to an infrared picture after it has been taken?
So you take an image, right, and you have your target, and you have the distance to your target, and you focus your camera if you have some sort of manual focus. So there's certain things that you cannot change right after you take an image. If you wanted a picture of something else and you took a picture of this target, that cannot be changed. Same with the focus. But as far as being able to add temperature measurements, add boxes, and add additional spots, being able to change the color palettes, right? That's something you can do after you've taken the image. There's many types of adjustments, or thermal tuning we call it, that you can do after the image has been taken. You can do this through the desktop software, through the mobile app, or through Ignite, the cloud software. Right in your browser, you're able to manipulate that image and change a lot of different things about it. So yeah, it's a JPEG with a lot of metadata. All the temperature points are embedded into that image. So yeah, there's a quite extensive level of customization and changes that you can do to that JPEG. That's a great question.
But there are a lot of defaults that you could use to do that, but you can't change the image by itself.
Yeah, and then there's the parameters you have as you take that image. So let's say you want a specific color palette, or let's say you want specific spots on the screen, but then after the fact you want to change that, you absolutely can.
Thank you very much, Heliel. Now, can the acoustic camera detect CO2?
It can. So you just have to look at, making sure you choose the right model. So there's, again, a lot of the applications, a lot of these gases, we're adding more modes to these cameras. So yeah, you absolutely can. The short answer is absolutely yes.
Fantastic. Now the next one I even know, so but I'll let you answer that question. Can ultrasound imaging point to problems in bearings?
Absolutely, right? So we know they're making sounds and you can't necessarily hear them. There is a mechanical mode in our camera, so you'll be able to fine tune to those frequencies, right? So understanding that that sound is different from, you know, pressurized air, it's important, and the camera, as you choose the right mode, will allow you to detect, you know, potential issues with bearings. Absolutely.
Super. Now, the next question is about hazardous environments. One of our customers is working in an explosion-free environment, or ATEX. And the question is, do you offer cameras for hazardous environments, including ATEX?
Yeah, so I touched on just one model with acoustic, the SI2X, is for hazardous environments, but we also have an infrared camera, the CX5, also for hazardous environment. So whether you're looking at infrared or acoustic, yes, there is one option there that you can use. So again, CX5 for thermal and SI2X for acoustic.
Super. I think the other question is then maybe already answered. How much training is needed to operate a thermal camera? I think that's linked to one of the first questions then.
Yep. It's
yeah, exactly. So
basically understanding the basics of infrared, right? So you can make the right decisions, and you can take the your thermal image from the right angle, avoid reflections, understanding emissivity, understanding, you know, which color palette you want to use, different things. But yeah, so it's up to you, right? Do you want to take an online course? Do you want to read about all these different things that impact IR measurement accuracy? Or do you want to go all the way and take the 3 levels of infrared training, right? Levels 1, 2, and 3, which we also offer.
yeah, exactly. I think the questions are then done, but I think that I have a question still. So you have a far broader range than just thermal imaging, acoustic imaging, and etc. Is there something that you would like to highlight as a new offering to the customers now that we have them on the call anyways, where you say this is interesting for you to look into as well?
Absolutely. So FLIR also owns the X-Tech brand. So if you're looking at, you know, other types of products, temperature, humidity, you're looking at tachometer, right, to measure RPMs. You're looking at a power analyzer. There's also the X-Tech offering, many different products, right, in our X-Tech brand as well. But as far as the new things on the FLIR brand, I would like to highlight the fixed vibration sensor. Very easy to integrate, very easy to deploy, and it's if you don't already have some sort of fixed vibration sensor, please take a look at the SV88 and SV89 on the RS website.
Yeah, that definitely needs to be part of your predictive maintenance plan. Definitely. So thank you very much, Heliel. We're out of questions, so I think that I'll do the closing. Thank you very much for your attendance today. As I tried to explain in the beginning, we are your preferred high service distributor. We have a great human touch, and we can support you on your premises. We can support you on the end-to-end journey as a business partner for you together with FLIR. As said, we invite you to invite us to start the transition from reactive to predictive maintenance. And many thanks for your participation today.